So the burning issue now is how to find this A, B, and C, right? This A, B, and C. Because what they gave us is this length, right? This AB, this triangles. But we do not care much about the triangle because that doesn't help us in finding the volume of the tetrahedron on this corner. Okay, so let's see how to find the length of A, B, and C. Okay, what are we going to do? You need to know a few things. First of all, let's see this encompassing box. So that's what I drew here. And to make it easier, I know this will give me wrong answer, but I will just make this box big enough so that you can see the whole motion, so that you can follow my logic through. Okay, here we go. Now, I will call this side A, this side B, and this side C. So ABC, these are labels, and this is length here. Lowercase ABC are the length. Okay, on this, I'm going to draw the diagonal that goes like this. The blue line is the diagonal that in space that runs across the box here. How long is it? Well, you know how to do that, right? I just said this length is A, this length is B, this length is C. So let me be truly kind to you. This length will be square root of A squared plus B squared, right? Okay, now if you look at this triangle, the hypotenuse will be square root of A squared plus B squared, right? I just use one leg, and the other leg squared. That should equal to A squared plus B squared plus C squared, because the square root and square canceled each other. So this A squared plus B squared becomes free. So what am I getting at? I'm telling you this blue line is square root of A squared plus B squared plus C squared. Okay, very good. But I want you to realize here, in any box like this, rectangular box like that, that's not the only one with that length. This one will have the same length. Let me just show you this. This has exactly the same length as the blue line you just saw. Why? How could I say that? I could say that because, it's still ABC. It has the same good old ABC. Let me show you here. That red one has, this is A, that's B, and that's C. So if you draw a triangle like that, it's A squared plus B squared here. And you know the rest of the story, this triangle. So you get the same distance. Now, why stop there? This one has hard to see, but you see it. That guy also has the same length because it has the same ABC on the side, right? Okay? And the rest, this one also has the same length. So when it comes to this spatial diagonal of a rectangular box, they're all the same length. So why don't I show you all? All these four have the same length. Okay, you see them all, right? And they are namely A squared plus B squared plus C squared. So I will use whatever I prefer, and at the moment, as I go through this derivation, I will just pick any one of them that I please, and I will say all of them are square root of A squared plus B squared C squared. Okay,